Picture two people sitting at the same kitchen table, both trying to build a future. One of them sets aside $24,000 over their life. The other sets aside $72,000, 3 times as much money. Common sense says the bigger saver should finish far ahead. But they don't. The person who saved only a third as much actually ends up richer. Not by a little, by a lot. By the time this video is over, you'll see exactly why, and it all comes down to one quiet idea most people never truly feel. That idea is compound interest. You've probably heard the phrase 100 times in a classroom, a brochure, a relative's offhand advice. But the standard textbook definition, all percentages and formulas, hides what's actually happening underneath. It tells you what compounding is called without ever letting you watch it work. So let's throw the jargon in the trash. Instead of memorizing a definition, we're going to follow the money itself, dollar by dollar, year by year, and watch it move on its own. Once you see the motion, the so-called trick stops being mysterious and becomes obvious. Let's start as simple as possible. Imagine you set aside $1,000, and it earns 8% a year. We'll use 8% purely as a round, easy illustration. With plain, simple interest, the math never changes. You'd earn $80 every single year. 80 the first year, 80 the second, 80 the third, the same flat payment over and over like a clock ticking. After 5 years, you'd have collected $400 of interest. That's steady and dependable, sure, but notice the shape of it. It's flat. The 80 never grows, never speeds up, never rewards you for waiting longer. Now let's switch on compounding and watch what changes. Year 1 looks identical, your $1,000 earns $80 exactly like before. Nothing surprising yet. But here's where the two paths split apart. In year 2, you're no longer earning interest on just $1,000, because your balance isn't $1,000 anymore, it's $1,080. So you earn 8% on that larger pile, which comes out to $86.40. Read that again. Your interest just earned its own interest. The money you made last year started working for you this year, quietly, without you lifting a finger. Here's the single line worth tattooing on your memory. Your money makes money, and then that money makes money. It's a loop that feeds itself. Watch it keep rolling. In year 3, you earn $93. In year 4, $101. Each year's payment lands bigger than the year before, and not because the interest rate changed, it stayed at 8% the whole time. The payments grow because the pile doing the earning keeps getting bigger. Every dollar of interest becomes a new little worker, and next year those workers bring back interest of their own. That's the engine. Now step back and look at the shape each path draws over time. Simple interest traces a straight, predictable line, same rise every year, flat and unremarkable. Compound interest draws something completely different. A curve that bends upward. At the start, it's underwhelming. It barely looks different from the straight line, and that's exactly why people give up on it early. But give it time and the curve starts to lift, then climb, then truly soar. That upward bend is the entire game. And here's the catch, it only ever appears if you let time pass. So how do you get a quick feel for how fast this curve grows without doing heavy math? There's a handy shortcut called the Rule of 72. You divide 72 by your interest rate, and the answer tells you roughly how many years it takes your money to double. Let's run it at our 8%. 72 divided by 8 equals 9. That's it. So at 8%, your money doubles about every 9 years. It's a rough estimate, not a precise law, but it gives an instant sense of the pace. And once you see the pace, the next part gets striking. And here's where doublings start to feel almost unfair, because they don't just add up, they stack on top of each other. Start with $1,000. After 9 years, it becomes $2,000. Wait another stretch and $2,000 becomes $4,000. $4,000 becomes $8,000. $8,000 becomes about $16,000. So over 36 years, that single original $1,000 has quietly grown into roughly $16,000. And remember, you never added another cent along the way. The same starting dollar, simply left alone with time, multiplied itself over and over while you went about your life. But look closely at those doublings because they're not equal in size. The very last jump from 8,000 to 16,000 was bigger than all the earlier jumps put together. That one leap added $8,000. The first leap, way back at the beginning, only added 1,000. So the earliest years genuinely felt like nothing was happening. It was easy to feel discouraged. Yet the final years did almost all the heavy lifting. That single fact, That the biggest growth comes at the end is exactly why when you begin matters more than nearly anything else you can control. So let's take everything we've learned and make it real with two ordinary savers. Both of them put in the exact same amount, $200 a month. Both earn the same 8%, compounded once each year. They're identical in almost every way, same monthly habit, same return, same goal of reaching age 65 with something built up. The one and only difference between them is timing. One starts early and one starts late. Same effort coming out of the wallet each month, same patience required, but, as you're about to see, two wildly different finish lines await them. Meet Emma. She starts at 25, fresh and early, while retirement feels like science fiction. She puts in $200 a month for just 10 years, and then, at 35, she completely stops. Life gets busy, priorities shift, and she never adds another single dollar after that. Add up everything she contributed and it comes to $24,000 total, paid in over that one decade. At 35, the moment she walks away, her balance sits at about $34,800. From there, she does nothing at all. She simply lets that pile sit, untouched, and gets on with her life. Now meet Leo, who does the exact opposite. He doesn't start in his 20s, he waits until he's 35, right when Emma is quitting. Then he begins putting in the same $200 a month. But Leo is relentless about it. He keeps contributing for 30 straight years, never skipping, all the way to age 65. Tally up everything he set aside and it comes to $72,000 out of his own pocket. That's 3 times as much money as Emma ever contributed, and 3 times the years of steady discipline. By every obvious measure, Leo looks like he should win this easily. So let's fast forward and meet them both at 65, the finish line. Leo, who faithfully put in $72,000 over 3 full decades, ends with about $272,000. That's a genuinely good result. His discipline absolutely paid off. But now look at Emma. She stopped saving 30 years ago. She contributed only $24,000 and then walked away in her 30s. And she ends with about $350,000. She finishes ahead of Leo by roughly $78,000, having saved less money, for fewer years, and quitting decades earlier than he did. Sit with how strange that result actually looks, because it defies every gut instinct. Emma set aside only a third of the money Leo did, stopped while he kept grinding for 30 more years, and still crossed the finish line in front. So what made the difference? It wasn't her contributions, those were smaller. It wasn't her effort, she put in less of it. The entire gap traces back to one thing, her 10-year head start. Because Emma's dollars went in earlier, they got to sit through extra rounds of doubling. Those big, late-stage doublings that Leo's money never had enough time to earn. This is the real, hidden cost of waiting, and the cruel part is that it's completely invisible in the moment. When you skip saving in your early 20s, it doesn't feel like you're losing much. It feels like you simply kept a few $1,000s. But that's not the true price. The real price is the final, biggest doubling those early dollars would have reached decades later, the one that adds the most of all. Delay isn't some small, harmless tax you barely notice. It quietly reaches into the future and removes your single most powerful stretch of years. So let's pull the whole video together in one breath. Compound interest means your money makes money, and then that money makes money, looping and feeding on itself year after year. The curve it draws rewards time far more than it rewards size, which is precisely why a small amount started early can outgrow a large amount started late. That's the entire lesson of Emma and Leo. So the real takeaway isn't simply to save more, though saving is good. The deeper point is this: your earliest dollars are your most valuable ones, because they're the dollars with the most time left to compound.